Hello, welcome to chapter 8.4, Shake, Rattle and Roll of the Dynamic Earth. This subchapter is talking about earthquakes. The picture you're looking at now is a picture of Nepal, Kathmandu in particular. As you can see, the devastation that is caused by such catastrophes as major earthquakes, and we're going to look at exactly how they occur and what causes them in the movements of the earth. Earthquakes are they're seen from the way that we see them, at least on the surface of the earth, but they're really caused by movements up to 700 kilometers below the surface of the earth, and they're caused by all these movements that we've been talking about. This movement of subduction, which if you remember was when the two plates were pushing into each other, and one of the plates is slipping underneath the first one. That causes, obviously, it causes a pretty major earthquake. It also, for when the plates are moving apart and they're separating, and magma is bubbling up in the resulting space, causing volcano and such things underwater. This can also cause significant earthquakes, and even the third one, which is where the two plates just rub up and down next to each other rather than applying pressure into each other or away from each other. So two terms that you should become familiar with. One is the epicenter, which is up here. The epicenter is seen to be directly above, however far the distance is, directly above where the fault occurred. Okay, if the fault or where the movement began at this point, okay, the point just directly above it is the epicenter. This point here is actually called the focus. So the epicenter is on the surface and the focus is underground. The epicenter is on the surface and the focus is underground. Okay? Now, the way we can determine where this epicenter is through the use of what's called triangulation. Okay? What we need is tri, meaning three. We need three seismometers, and we'll talk about what they are in a second. But a seismometer is a machine that can detect how far away the epicenter is. But the seismometer doesn't know which direction. Okay? It's really just a pen bouncing up and down on a piece of paper. It doesn't know which direction it came from, but it can tell how far away it is. So if we look at seismometer 1, it knows that the distance is somewhere in here. It's about this far. Okay, so if we know it's about whatever it is, 30 kilometers. Okay, then we get a map and we draw a circle around 30 kilometers. Then we'll know it's somewhere on that circle. All right, then we have a second seismometer, and we know that it's maybe 15 kilometers, 20 kilometers. Okay, then we get out a map and we draw a circle. Okay, and we know it's somewhere on this circle. At the moment, what we could decide is that, we've drawn two circles, one circle here and one circle here. We could say that it could either be here or it could either be here. That's why we need a third seismometer. This one here. And this one might say, oh, it's only about 10 kilometers from that one. So we'd get this one and draw the third circle. And then the only place where all three of these circles connect or intersect is at this point here. And that means that we know that this point here is the epicenter. Okay, so I did say that a seismometer was basically just a pen bouncing up and down, and that's really what we are looking at here. So this is a rotating drum of paper. Okay, this is old-fashioned now. They don't actually do it like this anymore, but you get the idea. We get a rotating drum. So this is a piece of paper that kind of comes through and just slides out. like that. Imagine a support stick, a spring, a pencil, our pen, and a heavy mass. So when the solid rock underneath starts to bounce up and down, the spring will bounce up and down, meaning the pen will bounce up and down, which will mean that it will draw on the paper. And as the drum is rotating round and round in circles, it will draw these kind of bumps and whatever else that we see here. So as the jolts come through, we're going to see the jolts result on here. Okay? Just like that. Great. And this is called the Richter scale. Okay? So the Richter scale, again, it's not used so much anymore because they have some better measurements, but it does give a good idea as to what is going on underground and what to expect in the future. Okay, so earthquakes measuring, less than 2, I suppose, on the Richter scale, are kind of like microquakes, and they're rarely detected by people. It's not very significant. Earthquakes of 5 on the Richter scale are quite detectable and probably move, some books on the bookshelf, or, your coffee cup might rattle a bit, but nothing really significant. But an increase from there of 1 is like a 30-time fold increase. So to go from 5 to 6, it's like 30-fold worse, okay? Or 30 times bigger. That means a 6 is 30 times the amount of energy that a 5 would be, and a 7 would be 900 times the amount of energy that comes from a 5, right? By the time you get to 7, it's more than just rattling your coffee cup. So there are 2 different types of waves, 3 really, actually. The first kind of wave you'll generally see when there's movement is called the primary wave, or the P wave. The P wave is basically just energy or movement through the surface of the rock. Okay, you get the rock being pushed out in all directions in this kind of manner. Okay, and that's the first energy you'll see. But that's kind of it's a compression wave. It's often underneath the surface, and it's very rarely felt. Okay, the second type of wave is a combination of this kind of movement and that kind of movement. So you end up getting a bit more of a shake and shiver. But again, it's not really felt underneath the earth. The last kind of wave is the most dangerous, and these are the L waves. These are the most dangerous because these are the ones that are felt on the surface. Those are the ones that do the damage. And we can see this. This is the seismometer. So it's saying that the paper moves this way. Okay, so imagine if the paper is moving this way and the pen is staying still, that means it's almost like the pen is moving that way. So this is, as time increases, we're going this way. So this is just nothing, just noise. Okay, and then we feel this first P wave. All right, and we go boom, 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 boom. And then the person watching the seismometer starts to freak out a little. Okay, and it settles down. Okay, now we don't want to relax now because we're going to see the S wave, and we get a larger response. The secondary wave is hit, and this SP time interval will give us some idea of when this is going to occur, but it's not much to go on, and we really don't have a very good warning system as for when this L wave is going to hit and buildings start falling over. Okay. You can see here, just kind of a graph of a picture about how the waves move through. The P wave is kind of, more through the center of the Earth. The S waves kind of through the more the magma and whatever else. But the L waves go around the surface of the Earth. They kind of don't go through the Earth at all. Sometimes the effects of an earthquake can be felt, in faraway countries than where it actually occurred. And this most often is caused by tsunamis. So the tsunami occurred just outside Indonesia on December 26, 2004. An earthquake occurred just outside Indonesia in 2004. And then these, you can see these areas here were affected. But you can see, as a result of tsunamis, all the way through Thailand, Myanmar, India, both sides, all the way around the other side of India, Sri Lanka, and even Somalia, all the way over here, was affected quite seriously by an earthquake, on the other side of the world. Maldives and other areas certainly were negatively affected as well. Caused by, a seismic activity, some kind of earthquake here, causing fast-moving waves. Okay, as the water gets shallower, the crests kind of are pushed in together. Okay, then were all kind of pushed in together, and ended up being higher and closer together, and these are the waves that cause all the damage. Okay, so that's all we're looking at today. So go to chapter 8.4, check out the blue words, copy them into Quizlet, and I'll see you in class.